Example 4 asks us to find when the particle is at rest. So this at rest, what that means is important. All right. So we need to, at rest means that both components of the velocity vector are equal to 0. So the horizontal component of velocity is 0 and the vertical component of velocity is 0 at the same time. Right? So we don't want to find them separately. So we know that velocity is the derivative of the positions that we were given. So we have 6t squared minus 30t plus 36 for my x velocity, and 3t squared minus 6t as the derivative of the y position, so the y velocity, the vertical velocity.
There are some car keys in front office if anybody has lost them. Car keys in front office if you have lost your keys. Bye.
So we're going to set these both equal to 0. The x and the y velocity. So here I can divide by 6, so I get something. I can divide everything by 6 and I get this nice quadratic which will factor for me, and I get t equal to 2 and t equal to 3. Alright, I'm going to do the same thing with the y component of velocity. 3t squared minus 6t equals 0. So I can factor out a 3t, and I get t equals 0 and t equals 2. So as I look at these, I notice here's when they are both equal to 0. The horizontal component is equal to 0 when t equals 3. The vertical component is equal to 0 when t equals 0, but those are not at the same time, so the only time that both are equal to 0 at the same time is t equals 2. So my answer to this would be the particle is at rest at t equals 2. And that the reason for that is that x prime of 2 and y prime of 2 are both equal to 0. Next one we have, we're asked to find the position of the particle at t equals 1. So they tell us the velocity vector, and they give us a position when t equals 0, and they ask us to find the position when t equals 1. Alright, so when we do that, we say, okay, well, the horizontal position, x of 1, is equal to the position at time equals 0 plus the change in the position between 0 and 1. And the change in the position from 0 to 1 is the integral, the definite integral from 0 to 1 of the velocity vector. Alright, so we can do that. We have 7 plus, here we get t cubed minus 2t squared. And we're going to evaluate that from 1 to 0. So I have 7 plus, when I plug a 1 in here, I get 1 minus 2, so that's negative 1. Minus, well, I plug a 0 and I get 0. So I have 7 plus negative 1 is 6. Y of 1, we started at negative 4, and we're going to add the change in the position from 0 to 1 of 8t cubed plus 5 dt. So it's negative 4 plus, I'll have 2t to the 4th plus 5t, evaluated from 0 to 1. So that's negative 4 plus, let's see what we get here. We're going to get 2 plus 5 is 7, minus 0 plus 0 is 0. So it looks like that's negative 4 plus 7. We get 3 from that. So the position vector at t equals 1 is 6, 3.